Hello, everybody, and welcome to this video that is all about reviewing what we know about projectile motion and doing a couple problems with it. So keep in mind there are two kinds of problems that you could be asked. One of them is where you're given the function, you're given h of t, and you're asked to interpret what some of the numbers, what the other coefficients mean, the b and the c mean. The second one is where you're given information and then you have to write the function. Let's see what I'm talking about. Let's take type 1. So in type 1 here, I'm told that the height of an object that's been thrown off a cliff can be modeled by the function h of t is equal to negative 16t squared plus 8t plus 224. And the first question that's being asked is, what do the 8 and the 224 represent? So why aren't they asking about the negative 16? Well, the negative 16 is always going to be there as long as we're talking about feet, because that has to do with the acceleration due to gravity on Earth, which is 32 feet per second squared. And as we talked about before, the actual formula is 1/2 at squared. So half of 32 is 16, and it accelerates downwards. It accelerates towards the center of the Earth. So that's why it's negative 16. So I'm not going to ask about that. However, the 8 and the 224, that's fair game. So my linear coefficient is 8. And we've seen before that this is our v naught. That's our initial velocity. Now, if all you write is the initial velocity is 8, you're not really telling me you understand exactly what's going on here. So yes, it's 8, but important to note is that it's positive 8. Since it's positive 8, that means that it is being thrown upwards. So the velocity isn't just velocity and speed are different. Speed can just be, okay, it's 8 feet per second, but velocity is speed with direction. And since the 8 is positive, the direction that it's traveling is upwards. So this is an initial upward velocity. So I'll say this: if v naught is positive, then that means that it is being thrown upwards. Okay. So if V naught is negative, then that means it's being spiked. It's being thrown downwards. Okay, well, what about if V naught 0? If it doesn't have any initial velocity? Well, that actually means that it's dropped. You're not throwing it up. You're not throwing it down. You're just holding it and letting it go. That means our V naught is 0. Okay. Well, in this case, V naught is 8. So I could say that the 8 means that the object, I don't know why I'm not typing this, was thrown upwards at 8 feet per second. Okay, so a couple of things that need to be in this answer in order to, receive all of the possible credits. So tell me that it's being thrown upwards because it's positive, and give me the unit. It's feet per second. How do you know it's feet? Well, the negative 16 tells me feet per second squared. So that's how I know it's feet, and that's how I know it's seconds. Okay, the other number that they're asking about is this 224. This was our h naught. So again, if you just say the initial height is 224, I guess that's better than just saying the initial velocity was 8. But go back to the context of the question. Always try to answer things in the context of the question. We have an object that's being thrown off a cliff. So if the initial height is 224, in the context of the question, that tells me that the height of the cliff is 224 feet. That's a big cliff. Okay. Now, I guess that really does kind of ignore the height of the person who's throwing it, but, you know, for all intents and purposes, we can just go with the height of the cliff is 224 feet. Now, both types of questions are going to ask this: when does the object hit the ground? It's asking when, which means we're trying to solve for t. We're solving for a time. And when does it hit the ground? Well, what's the height of the ground? The height of the ground is 0. Or you might hear something that's being thrown into the water off the bridge. The height of the water is 0. Maybe you'll have a question that says, when does it hit the roof of a building that's 8 feet tall? Okay, then we want to say, when is h equal to 8? But in this case, we're asking when does it hit the ground? So when is h equal to 0? All right, let me give myself a little bit more space, and we'll solve this quadratic. So we are told that negative 16t squared plus 8t plus 224 models the height of the object. And I want to know, when is that height equal to 0? Okay, I'm going to start this by pulling out the greatest common factor, which isn't just 8, it's going to be negative 8, because I always want to pull out the negative. So then I'm left with 2t squared minus t, because I'm pulling out the negative, so that plus 8t turns to minus t, minus 28, as 8 goes into 224 28 times. And that's equal to 0. Now, if this were just a factoring question, I have to keep the negative 8, but it's not. I'm solving. So I can divide both sides by negative 8. 0 divided by anything that's non-zero is 0. So negative 8 ceases to exist. Now I'm going to hope that this factors. I'm going to guess and check. So 2t squared is great. It's just 2t and t. 28, there are a bunch of ways to break it up, but I'm going to bet that it's 4 and 7 or 7 and 4. And I think I want a plus 7 and a minus 4, because that'll give me minus 8t plus 7t. Yeah, that's minus 1t. So that's good. So I guessed, it checked, I'm good. Now there are two possible solutions here. Either t is negative 3.5, or negative 7 over 2, or t is 4. T is time. And in the context of the question, we're asking, when does something hit the ground? To say that it hits it in negative 3.5 seconds doesn't make any sense. The object isn't going back in time. That gets rejected. The only thing that makes sense here is t is equal to 4 seconds. That is when the object hits the ground. Okay, so that was type 1. Now on to type 2. Type 2 gives us information. It says the object is thrown upward with an initial velocity of 12 feet per second from the top of an 88-foot tall building. Part A, write a function that represents the height of the object with respect to time after it's thrown. Okay. This whole thing that write a function that blah da blah da blah da blah da blah da blah da blah. They want h of t is equal to, just like what you saw in the last problem. You can kind of get a little lost in the vocabulary and stuff here, but it's just asking, write a function like you saw in type 1. Okay, well, we know we're going to start off with negative 16t squared. We're always going to start off with negative 16t squared. Maybe when you get to high school, you'll be dealing with meters, but there's feet, there's seconds, it's negative 16. Okay, what's the rest of it? It's being thrown upwards 12 feet per second. So that's going to be plus 12t off of an 88-foot tall building. There's my initial height. So the information in the question gave us the initial velocity and the initial height. So that's part A. And then part B, same as the last one, when does it hit the ground? Okay, so let's set this equal to 0 and solve for t. So negative 16t squared plus 12t plus 88 is equal to 0. And again, I'm going to factor out the GCF, which in this case is going to be 4, or negative 4. And then I'm left with 4t squared minus 3t minus 22 is equal to 0. All right. Let's do some guessing and checking, and hopefully this doesn't take too long. My first thought is going to be 2t and 2t. Although 22 is even, which means no matter how I break it up, one of these two numbers has to be even. And that's going to create a GCF that's not there. So 2t and 2t doesn't make any sense. I'm going to need a 4t and a t. Okay. So why don't we try 4t plus 2, and then this would be a minus 11. And I think that's going to work, because now I'm going to get plus 8t minus 11t. That's minus 3t. Okay. So I can ignore that negative 4 in the beginning, divide both sides by negative 4, it goes away. And then I have two possible scenarios. Either 4t minus 11 is 0, which means t is 11 over 4, which is 3 3/4 seconds. Oops. So So 3.75 seconds. Okay, that makes sense. Or I could say that t plus 2 is 0, in which case t is negative 2. And then, just like in the last problem, that means we are going back in time 2 seconds. That doesn't make any sense. So the only thing that works here is t is 3 3/4 seconds. So after 3 3/4 seconds, the object is going to hit the ground.